This is a video that will summarize the work that you need to do for the first week of Physics 157 at Camosun College. The PowerPoint slides that are on D2L should be your reference and should also be your source of notes for the course. The video here will just basically summarize what it is you need to be working on and the basic concepts that you'll need. So this should really just be review from your previous physics course. Some of the review topics will be sig figs, and the rules are laid out in the PowerPoint. The tricky thing are the zeros. So if you were to have a measurement that looks like that, these zeros are not significant. They are simply placeholders to let you know that that 1 is a 1/1000th. This zero, however, is significant because it's there to let you know that the next digit is a 0. It's not a 1 or a 5 or something else. It doesn't need to hold a place. It simply needs to tell you that that is the actual digit. Something else you're going to have to review are your SI base units. These are the units that all physical quantities can be written in terms of. They're the meter, the kilogram, the second, the Kelvin, the candela, the mole, and the ampere. Okay, in this course, we will be seeing mass, distance, time, temperature. I don't think we'll do candela or moles, but nor will we do amperes. But so these 4 we will come across in this course. Okay, and then the kinematics, basic definitions in kinematics. You should know the difference between displacement, which is a vector quantity defined as the change in position, x final minus x initial. That's for one-dimensional motion, an object that is going back and forth on the x-axis. Distance, on the other hand, is simply the length of the path. It is not a vector, it is just a number, just a scalar. So distance is length of path. Speed is distance over time. And that is also just a scalar. Units are meters per second. And velocity, that is a vector. And so it's v, and in one direction it's the x component, and that is defined to be the displacement over the change in time, also in meters per second. Okay, so there's a couple of questions that you have. Remember, if you're doing average speed, so if something is going back and forth, you simply take the total distance. Doesn't matter whether it's going to the right or to the left. You add up all the distance and divide by the total time, including any time that you sit around and rest during the trip. So that's average speed, whereas average velocity, which could be a completely different number for the same trip, that is just the change in position over time. So the change in position is simply where you end up minus where you start. Whether you've gone back and forth is irrelevant, other than the time it takes to do the trip. Okay, there's some lovely videos on Mastering Physics that you can watch about acceleration, the vector nature of acceleration, when acceleration is positive or negative, what that means in terms of velocities and displacements. So that's definitely a video to watch. The definition of acceleration is change in velocity. If you're going to be in the x direction, you put an x with time. And you will have some questions where you're asked simply to find some accelerations. As far as the one-dimensional kinematic equations, they are also given on the PowerPoint slides, and all the details of the quantities are there. You should probably, well, it'd be a good idea to memorize them, but VF is VI plus AT. Delta X is VIT plus 1/2 AT squared. Those are probably the most common ones. And then you have VF squared is VI squared plus 2A delta X. And delta X is half VI plus VF times t. And remember that these equations only apply when the acceleration is constant. So if it's a multi-part trip, you must break it into the parts where the acceleration is constant for each part. Okay, and you'll have a few examples to look at in the PowerPoint slides, and then you'll have some questions on mastering physics where you'll be asked to use these equations to do some calculations. Also in these first couple of chapters are free fall. And remember, with free fall, doesn't matter whether the object is going up or down, or if it's in the air and nothing is acting on it except gravity, it is in free fall. And this is when you can use the acceleration is negative 9.8 meters per second squared. Always, always, always negative. Do not switch that to a positive number and decide to make the direction down positive. That's just crazy. Down is always negative. The acceleration is always negative. The force of gravity is always pointing toward the center of the Earth, which is defined to be the negative direction. And there are a number of videos of the author of your textbook doing lectures on free fall examples. There are video tutor solutions on free fall examples, and then you'll be asked to do that in your Mastering Physics assignment. So that is basically it for this first week.